Yes, I start. So, good evening. I welcome you all for the week 1 live interactive session for the course Polymers, Concepts, Properties, Uses and Sustainability. This course is taken by Professor Abhijit Deshpande of IIT Madras, and the live interactive session is handled by myself, Kritika, uh, PhD scholar, PhD PMRF scholar from IIT Madras. So let's get on to the session. Let me share my screen. Okay. So, uh, so before getting on to the actual session, let's have brief introduction of each of you. Okay. Uh, so each one of you can start. Just say a brief of yourself, your name, from which university you're from, and what course you're doing, and which year. Okay. Hello. You're able to hear me?
Yeah, ma'am.
Okay. Okay. First, let's start with Kirti Vasan. Just give an introduction of yourself.
Myself, Kirti Vasan, ma'am. I'm studying in CPET. I'm doing my third year. My actual thing was to prepare for GATE, so I have been attending these lectures,
Okay.
and I hope this will be very useful for me to get good at GATE, ma'am.
Okay,
Thank you.
okay. I think we lost connection of Vijay Bharati. Uh, okay. Let's wait for a minute if she joins, and then maybe we'll continue with the session. Okay, just we'll wait for a minute. You're able to see my screen, right?
Yeah, ma'am.
Okay, okay. Okay, maybe let's get on to the session. Maybe once others join, no, let's have an introduction of them as well. But before that, we'll just start with the session. Okay? Yeah. So as I said, I'll be handling your live sessions, in this live sessions. So as you expected, you want to, get a good score in GATE. So it should be useful for your GATE, right? So definitely, I'm expecting that this will be useful for GATE because the session will cover a brief recap of the lectures of the particular week, and then we'll be solving some example problems, and this example problems will be a mix of some concepts, numericals, and a lot of gate questions will also be covered. Okay. You're able to hear me, right?
Yeah, ma'am.
Okay. Has anyone else joined? Okay, let's proceed with the recap of the lectures. So the week one had 7 lectures, correct? So the lecture one was, brief introduction to the course, where it started with why are polymers so common, right? Are polymers common, very common in, uh, are polymers commonly available, or is it, very rare? Is it
Yeah, ma'am. It's available in everyday life, ma'am.
yes, yes, it's available in everyday life, right? From your, your water bottle will be a PET bottle, right? your covers,
Yeah, ma'am.
polythene covers, polythene bags, right? In fact, we are made up of lot of polymers. Our tissues are made up of polymers, right? Our DNA is a polymer, right?
Yeah, ma'am.
Yes,
Nucleotides and polysaccharides,
yes, we are made up of.
protein caseins.
Yes, yes, yes. So polymers are ubiquitous, right? So there was a discussion on advantages of polymers. So where their mechanical response, what are the the real advantages of polymers? What makes them really becoming ubiquitous materials, right? You have variety of response. They can be rigid, right? Like your PET bottle, it's rigid, right? Or your rubber sheet, which is very flexible, correct? So there is a wide
Yeah,
range.
ma'am.
And then ease of fabrication, right? The cycle time of fabrication, it can be as less as 1 second. The cost is very less, right? Because they are from these non-renewable byproducts of these uh, non-renewable sources like petroleum processing. They are byproducts, but that is also kind of a question of concern because of their, what is it, their non-sustainability, right? And then they are
Yeah, ma'am.
durable. So some of the disadvantages of polymers were also discussed, right? Some, their physical aging, some standard properties because of the macromolecular nature, so polymers are macromolecules, right? They have n number of monomer units, right? So because of that macromolecular nature or being a giant molecule, the property varies, right? In
Yeah,
fact,
ma'am.
they are mostly polydispersed than a monodispersed. All your synthetic polymers, many of them are polydispersed in nature. So the properties varies hugely. So that might be a, a point of disadvantage. And then their physical aging and thermomechanical stability also, right? And again, performance. So you may not get as same performance as a metallic, uh, right? Metals, right? But still you get some performance which are sufficient for a particular purpose, but not as same as some metals. For example, they cannot be as perform as same as a steel, correct? Or they cannot conduct as good as a copper, but still there are conducting polymers, right? And
Yeah,
of
ma'am.
course the
Follow.
aspect of sustainability. And then the advanced application, right, was discussed, from plastic electronics to plastic solar cells, where it is not only the casing but the each and every component, the conducting part or the semiconducting part, everything, it is made up of these polymeric materials. Soft robotics, correct?
Yeah,
Instead of
ma'am.
rigid robots of metal, connected, now there are a lot of soft robots, right? You would have seen, some YouTube videos showing some octopus like movement, right? Some snail like movement and all, right? Soft robots, right?
Yeah,
And
ma'am. For transports and for picking up the products and delivering it, they'll be using it.
yes, yes, yes. So, they are reducing the number of joints and all. When there is a metallic piece, you have to join with, and you have to fasten it in multiple pieces and multiple pieces to be, connected and all. Here with soft robots, because of the polymers, they are flexible. Their flexibility in nature and all. No, a single polymer piece can replace it. But of course, making it work, or on the target for picking up, as you said, picking up, uh, a particular object and all, no, there are a lot of understanding that has to be made, right? Physics is involved, right? Your calculations are to be involved, right? And then the discussion closed with the introduction to the course module, where the course module included concepts, properties, uses, and sustainability. So these were the part of you know lecture 1 of week 1. Then in lecture 2, so in lecture 2, what would be covered in each of the modules? Like the concept would cover why and how something, right? And properties will give the numbers, right? How much is the electrical conductivity? How much is the dielectric property, right? And then the uses where it can be used, for example in solar cells or in soft robots, right, or in packaging. And finally, on sustainability aspects as well, how you can make it more sustainable, maybe replace synthetic polymers with the natural polymers, right? The discussions were on that. And then the actual getting on to the concepts, right? Macromolecules, what are monomers, right? For example, in polyethylene, ethylene is a monomer, right? CH2 is a monomer, right? And then oligomers were discussed, correct?
Low molecular weights or oligomers.
Yes, yes. So they'll have the number of monomeric units will be less in case of a oligomer, correct?
Yeah,
And
ma'am.
then what is the
Yeah, ma'am.
diversity of polymers around us, right? What are the different natural polymers, synthetic polymers, and again in synthetic there are much more diverse varieties. In natural, again you have like polysaccharides, polynucleotides, right? So these were all discussed. And then you have copolymers, polymer blends, right? How you sequence the monomers. So copolymer can be two different monomers or three different monomers, right? And then what is the functionality? So how do they get actually get connected to form? So what is the functionality? For example, in a ester you have the diol group and dicarboxylic acid groups, right? So these were all discussed. And then the next was on the molecular architecture. So what is the backbone? So the major backbone is the carbon backbone, right? And then what are the different side groups you can have, right? What is the N group and what is the degree of polymerization, correct? And then on branching, right? The discussions were on different branching, and how branching, it may affect the processing or the density of the material, right? And then the molecular weight. So the molecular weight distribution. So these concepts were all briefed, given an introduction in the lecture 2. Correct? Correct. Hello?
Yeah, ma'am.
Yes. Yes. So did you have any doubts in these lectures in any specific?
No, ma'am. No.
Okay. Okay. So how the way architecture varies. You have networked polymers, cross-linked polymers, hyper-branched polymers. You have comb-like structures, star-like structures, star polymers, right?
Yeah, ma'am.
Yes. And then the segment, the molecular, macromolecular segment, right? So what is a segment? What is a segmental length for a cross-linked rubber? Correct. These were all discussed. And then lecture 3. So lecture 3 was on what are polymers and its unique features. So this was again on concepts, right? What are the proper process, structure, and property, right? They are interrelated, right? Right. So sometimes
Yeah, ma'am.
processing affects the structure, or sometimes structure affects the property. Structure structure may affect the process. So they are all interrelated, correct?
Yeah, ma'am.
Yes. And then in processing you have different kind of polymeric materials. You have maybe an polyethylene, right? It's a simple polymer, whereas a copolymer, polyethylene and polypropylene copolymer may also be there. Propylene group and ethylene group copolymer may be there. There may be a blend of polyethylene and polypropylene polymer composites where kind of fibers may be reinforced into the polymers. So these fibers may also be polymeric in nature, like your jute, right? Into the synthetic polymer matrix. Or sometimes these can be like some carbonaceous material, like your carbon fibers or graphene. So they form composites. Porous polymers are used, polymer charge complex. And again, in processing you have different kind of processing, like melt processing, shaping, how it affects, curing, solution processing, using a solvent, right? and then dispersions, right? Like in your paints, correct? So paints, the polymeric molecules are dispersed in some solvent. That's why you spray after drying, the solvent is evaporated, correct? Hi Manshi,
Emulsion.
Hello, ma'am. Very good evening.
good evening. So we just started brushing up the the lectures covered in the week one. So
And evaporator and gets solidified again, ma'am.
yes. So Keerti wasn't, just hold on for a moment. We'll welcome
Yes,
Manshi
ma'am.
also. So Manshi, just tell me about yourself before we continue into the brief recap of the lectures.
Yes, ma'am. I'm from Aligarh Muslim University, and I have just completed my bachelor's of vocational course in polymer and coating technology.
Okay, you've completed your bachelor's. Okay, that's nice. So welcome to the live interactive session on the course. So this live interactive session. So every week, how it will be is that you will be having a brief recap of the lectures covered in that particular week, and then you will be we will be solving some example problems. So example problems will be a mix of concept related problems. There will be numericals, and we'll also solve a lot of gate questions. Okay, so hope
Okay,
it
ma'am.
is useful. So now let's get back into the session. So we were giving a brief recap on the week one lectures, right? uh, so we were on the lecture 3. So we finished till the processing of it. Now let's go on to the structure and properties. So as it was discussed in the lecture, the polymers are neither solid nor liquid, right? Even if it is a solid polymer, it is going to have some liquid like features, and liquid polymer is going to have some solid like feature, correct? So do you remember?
Polymers have the viscoelastic property.
Yes, they are viscoelastic. So viscous means your liquid like behavior, elastic solid like behavior, correct? So someone remembers, what are the properties that were discussed in liquid like and in solid like behavior? Any of you remember? This is going to be, very interactive session. So just feel free to answer anything. Okay, there's nothing right and wrong. It's going to be a learning for both. Okay, and if something is wrong, I'll help in correcting you. Okay, so liquid like your polymer dynamics, as the polymers in liquid like state, they can move around, right? The segments are free to move. Okay, Sandeep, welcome. Hello Sandeep, you are able to hear me?
Yes, hello. Yes.
Yes. So we just started discussing the brief recap of lecture one, week one lectures. Okay. So before we continue, you can just give a brief on yourself, your name, from which university, which year of of your degree you're in, and which you're doing your BTech or MTech. Just give a brief. Hello,
Yes.
Sandeep.
Yeah, actually, I am from mechanical engineering background.
Okay.
Right now, I am doing research on the VAT photopolymerization. That is one of the 3D printing process. So that's why I choose a course to learn the basic things of the polymer and these things.
Okay.
So I think after complete this course, maybe I have some the knowledge about the polymer and especially the polymerization process. So that's
Okay.
why I choose this NPTEL course. Yes.
Okay. Very good. Okay. Welcome to the session.
Okay.
And Narayana Reddy, hi, you're able to hear me?
Yes, madam.
Yes. So just give a brief of yourself, your name, which university you're from.
Madam, my name is E. Narayan Reddy, madam.
Okay.
I am from working government polytechnic chemistry lecturer, madam.
Oh, you're a lecturer. That's nice. Okay.
Yes, madam. From Kadri, government polytechnic Kadri, madam.
Oh, okay.
AP.
Okay. Okay, that's nice. Nice.
Okay, madam. I will join part-time PhD.
Okay. So,
For course file purpose, I will join this polymers.
okay, okay,
My research work is based on polymers.
okay. Your research work is based on polymers. So, what exactly you're, researching on polymers? You started, or you will be joining on your set, right?
Just I will started, madam.
Okay, okay. So, what field you're working on
అంటే
polymers?
like benzoxazine, polybenzoxazine.
Okay. So, what is it actually used for, and what kind of some application are you going to, work on the synthesis, some
Yes,
alternation? Okay, on synthesis process.
synthesis.
Okay,
Yes, madam.
okay, okay, okay. Welcome.
By
Biosynthesis.
by applying like cancer agents,
Oh, okay,
reagent.
okay, okay, okay. That's nice. Okay, you'll be. That's good, good, good. Okay. So we actually started the session some 15 minutes back. I'm Kritika
Okay, madam.
and I'm a PMRF scholar, PhD PMRF scholar in IIT Madras. So I'll be handling
Okay,
this live interactive sessions. Okay,
okay,
we
madam.
actually started with a brief, recap on the week one lectures. Okay, so we were on to the lecture 3. So we'll just continue with that. Okay, you're all able to see my screen, right?
Yes, madam.
Okay, okay,
Yes, yes.
okay, okay. That's very good. So let's continue with that. Oh, we have maybe one more person joining. Harshal Patil. Hi, Harshal.
Yes, good evening, ma'am.
Good evening. So just give a brief on yourself.
Good evening, everyone. Myself, Harshal Patil. I'm working as an assistant professor in Department of Chemical Technology, UPL University, Ankleshwar.
Okay, that's nice. That's really great.
My major is polymer and surface coating technologies.
Okay. Oh, polymer is surface protein technology. Okay, okay, okay,
Yeah,
okay. Okay, that's nice. So welcome.
thank you. Thank you.
Okay. So we were actually, having a brief recap on the week one lectures. So we'll continue with that. We were on lecture 3. So we'll all continue with that. Okay. So, and one more thing before I continue, this session is going to be more interactive. So, a few things I just want to say. Try to go through the lectures, before attending the session, so that if you have any doubts, you'll just get it cleared in the session. If possible, I can clear it. Or also, you can, post your questions in the forum. We'll try to answer through the forum, or we'll just go through those questions and discuss in the next interactive session. Okay, and also please feel free to answer. It is going to be more interactive. Okay, feel free to answer. So each one may be an expert. We have some lecturer, we have some professor. So you will be having some expertise in some part of the polymer concepts, right? So feel free to answer, and it will be a learning for every one of us. Okay, there is nothing right and wrong. If something is wrong, I'll try helping you out. Okay, if I'm wrong, you can also try helping me out. Okay, so don't feel shy in answering anything. Okay, so can we just proceed with the recap? Someone can answer whether shall I proceed with the recap of the lectures?
Yeah, ma'am.
Yes.
Okay.
Ma'am. Yes,
Oh,
ma'am, we can.
okay. Okay. Let's continue. So we were discussing on structure and properties. So we have states of interest like liquid like, and their associated properties. So something like, in liquid like nature, there is a more segmental flexibility, correct? And then, properties like diffusion through the polymer network, swelling, correct? And then plasticization, viscoelasticity, all these, are some associated properties. Like swelling, you have these super absorbent polymers everywhere. You would have seen, kids diapers, how much it swells, right? Its weight, it has the capability to swell from 100 to 1000 times its weight. It's interesting, right? The polymer, it can take up the liquid, the water, nearly 100 to 1000 times its weight. That's very interesting, right? 1 gram of polymer can take up. Okay, so something like that. And then solid, like again you have associated crystallinity, and then the deformation behavior, the conductivity, right? uh, and then other properties also include your resistance to UV radiation, especially when you have packaging materials, food packaging and all, it should be resistant to oxygen diffusion, carbon dioxide diffusion, correct? So these properties are all critical. And then, as we said, you know uh, there is a property correlation, structure processing correlation, and processing and property correlation. So one may determine the other, or all three, one of them may be the dominant determining feature, and the others may be influenced by that, right? It's a triangle, correct? Property, structure, and processing correlations are, it's a triangle, correct? Okay, there is one more participant, Kushagra Goyal. Hi. Okay, we missed her. Okay, let's proceed. Next, in lecture 4, what are polymers again and its unique features? So here, the discussion was on uses, especially on biopolymers. So here, the classification of polymers, right, based on the monomers, was discussed, correct? Based on monomers and some common family of polymers. So someone remembers, what were the polymer based on monomer, the classification of polymers based on monomers? Someone remembers any? Hello? Someone is saying something. There is one more. I think I'm not able to hear you. And also, if you are not able to speak, or if you have some, issues in your mic, you can type in the chat box also. Okay, we'll see what answer you're giving. There is one more new joinee, Nishaj. Yes, hydrocarbon polymers. So, can someone give an example of a hydrocarbon polymer? Fluorinated
Polyethylene,
acrylic polymer.
polystyrene,
Huh?
polyethylene.
Yes, very good. Very good. Okay, there are two more participants. Uh, Polyesters, yes. Yes. So there are two more participants. Let's welcome them. One is Nishaj, and the other one is Mr. Sanjay. So Nishaj and Sanjay, can you just give a brief introduction on yourself, since this is the first class?
Uh, I am Sanjay Patel from Lucknow Government Polytechnic, Lucknow.
Okay.
I am lecturer in Plastic Mold Technology Department of Plastic Mold Technology.
Oh, okay. Okay. You're a lecturer. So
I have graduated in Plastic Technology and Masters also in ICT Mumbai, from ICT Mumbai Plastic Engineering.
okay, welcome. Welcome to the session. Nice. We have good mix of lecturers, professors, students. Nice. So it's going to be really nice interactive session. Welcome, sir. And then we have Nishaj Asari. Can you just give a brief introduction of yourself, Nishaj? Hello? Nishaj? You are able to hear me? Hi, Nishaj.
Yeah. Can you hear me?
Yes, 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 Nishaj. Please proceed.
Yes. Myself. I'm Nishaj. Actually, I'm working in Qatar.
Okay. Oh, you're joining from Qatar. Oh, we have an
Yeah.
international student also here. That's nice.
No, because I'm Kerala. Basically, Kerala. I'm working in Qatar for petrochemical company,
Oh, that's nice.
and in polymer field. Actually, this is in the polymer field. We are producing the polyethylene resins, means granules.
Oh, okay, okay, okay. Nice, nice,
Okay.
nice. So, welcome.
And I'm working as a application officer in technical customer service.
Okay.
And my educational background is BTech and MTech in polymer science itself
Okay, okay, okay. That's
from
nice.
KUSAT.
Oh, okay, okay, okay. Nice, nice. Welcome. So what we were doing is that we were actually having a brief recap on week one lectures. So let's continue that. Okay. And this session is going to be interactive. So I want everyone to give some answers and be very interactive. There's nothing right and wrong. So feel free to answer. Okay. Okay. So I think on classification based on monomers, I saw a lot of answers. Let's go through each one what they have. Yes, classification based on polyelectrolytes, ionic, poly. Okay, example some polyamide. Okay, silicon based, conjugated polymers. Okay, acrylic polymers, fluorinated polymers, hydrocarbon polymers. Yes, yes. Okay. So someone can say what is conjugated polymers?
It will have the alternate double bonds.
Yes, alternating single and double bond.
Yeah,
So
basically conducting polymers will have the class of this
yes,
case.
yes, 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 yes. Kirti Vasan has mentioned conductor. Yes, yes. So they have delocalization of electrons, right? Because of this alternate single and double bond. Correct? Yes, that's nice. And then what else we have? So ionic polymers. So it can be some example of a polyethylene with polyacrylic acid, right? The acrylic acid will have the COH group that can be ionized. So CO minus H plus, correct? Yes. Okay. Now let's go further on. And then we have different families like polyamides, polyimides, polythiophins, right? Polyolefins, right? And then polyacrylates. So these are different form families. And then based on origin, you have synthetic and natural polymers. So synthetic is your petroleum based, all your polyolefins like polyethylene, polypropylene. And then natural polymers. Again, natural polymers has three different, it can be again, of various classifications again, right? Correct. Any one of you remember some natural polymers? Anything?
Cellulose.
Yes, that's good.
Jute.
All the macromolecules is actually belong to natural, like jute, fibers,
Yeah, okay, yes. So you have
and
jute.
even we are discussing about the RNA, DNA, all the structures.
Yes, yes, yes. Polynucleotides, polysaccharides,
Yeah,
right?
saccharides.
Your
Yes.
pectin.
Polypeptides.
Yes, polypeptides, your proteins. Polypeptides are proteins, right? Your proteins. And then your polysaccharides like your cellulose, starch, pectin, right? Right from your pectin, for example, I think everyone would have eaten this jams and jellies, right? So these jams and jellies, they predominantly they have this pectin. Okay, it's not only about
Yes.
that, they are the matrix component, and they are basically the hydrogel forming agent, and they play a very important role in ripening of fruits. Okay, and lot of several other roles in plants. Okay, now next is some related terms like bio-based polymers. They are from natural resources, and then natural fibers, and then there was a discussion on polylactides, polyols, biocompatible polymers. So they need not be actually uh, from biological origin, but they are compatible with the human body, right? Like something that has to be used in your stents in heart, right? And then biodegradable polymers. Again, biodegradable polymers, they need not be really from natural origin, but they may be from synthetic origin but biodegradable. Okay, and then type of biomolecules based on type and based on origin, right? These were all discussed in lecture 4. Okay. Okay. Now let's see what was discussed in lecture 5. So lecture 5 was on the property molecular weight, right? The effect of molecular size, the length, right? The length of the, they are giant molecules, correct? Polymers are giant molecules, so their molecular weight, molecular size, they play, very vital role in the properties and all, correct? The effect of molecular size, how the viscosity with respect to molecular weight it will change, right? And different properties, the lengths, the branches, the blocks, cross links, monodispersity and polydispersity, right? How it is, the molecular weight distribution can be, calculated either through a discrete technique or through continuous. And then the different definitions like number average molecular weight, weight average molecular weight, viscosity average molecular weight, z average molecular weight, and then what is dispersity, what is a polydispersity coefficient. So these were all discussed in the lecture 5. And then what about lecture 6? So lecture 6 was on polymerization as such. Okay, so what is the goal of polymerization, right? How do you control the tacticity and chirality, and how do you control the sequence, branching, networks, and other architecture, right? There was discussion. And then what are the quantitative control that can be done, how do you control the average molar mass, molecular weight distribution, right? Segmental length, segment weight distribution, branching density, right? And the length of the branch, number of star branches, and then there was discussion on step polymerization, right? And then polymerization in olefins. So that is nothing but your free radical polymerization. Uh, Free radical polymerization is one of the example, where an active center is created, right? For example, in the case of polyethylene, right? These were all discussed. Hello, are you all there? You're all
Yes.
there?
Yeah, ma'am.
Oh,
Yes,
okay.
yes, yes.
Okay. So let's continue with our discussion. And then the final lecture of the week was on sustainability, right? So when you take the polymer structure, again, there are multiple scales in terms of length and time also, right? From your electronic orbital, right? To your covalent bonds, to your segmental length, to the entire macromolecule itself. And again, you have the time scales related to that as well. Something happening at electronic level will be very fast, right? Very short time scales, right? And then from macromolecules, how can you break down? Is it possible to break down? Is it possible to depolymerize? Is it possible to decross link, right? And what are what causes degradation, right? The scission of backbone, branches, cross links. So activation, how do you activate the degradation? So it can be through thermal activation or through photolysis, and then catalytic, enzymatic, right? Right, and then hydrolysis, radiolysis. And what are the questions related to sustainability? What is the life cycle cost, right? So we have to see the life cycle. It's not just about the processing, the start of raw material, and then finishing the processing alone. The entire life cycle, how it is functioning, and then how it is whether we are really able to break it down and uh, you know uh, get into the natural, completely biodegraded. So everything should be accounted for this life cycle assessment, right? The degradation in holistic manner. So the degradation should not be there during its service life, whereas it should start degrade once the service life is over, right? Otherwise, if it is degrading during the service life, that is also not good. If it is not degrading after service life, that is also not good. So we have to take real measures on all these things, right? How do you get in the polymers into the biogeochemical cycle? What are the challenges? So these were all discussed in the lectures of week 7, sorry lecture 7 of week 1, right? Now we have one more participant, Malavika. Hi Malavika. Hello Malavika, you're able to hear me? Hello, just give a brief of yourself Actually, we were giving a brief recap of our week 1 lectures. We just finished all the week 1 lectures brief recap. Now the next stage is going to be we are going to solve some example problems. But before we start into the example problems, let's have some introduction on Malavika. So Malavika, just give a brief on yourself. You're not able to unmute and speak. If you can unmute and speak, please do speak.
Hello, ma'am.
Yeah, that's good.
Am I audible?
Yes, you're audible.
So I'm Malavika. I'm from Kerala.
Okay.
So I'm recently graduated with an MSc in Polymer Science from Cochin University.
Okay. Welcome, Malavika. So
Thank you so
we just
much.
completed the brief recap. So every week, what we'll have is that brief recap of that particular week lectures. Okay, followed by
Okay.
we'll be solving some example questions. So this example questions will be a mix of some concept related questions, some numericals, and we'll also try to solve some gate questions as well. Okay, now we just finished the brief recap of lectures of week 1. Now let's get on to the practice assignment problems of week 1. Okay, and
Sorry to interrupt, but Mac, one thing.
yes.
What is which week is this going on? It is the first week for the course, or it's second or third week?
No, this is first week. First
For
week.
IT Madras, it's first week, right?
Yes.
For this course. And
Yes.
what about the assignments? We have to submit the assignments as well, now.
Yes. So assignments, I think you have your first week assignment deadline on Wednesday, 9th of August. I
It's
think that is
9 of August.
yes.
How where we can access these lectures? Actually, this is for the very first time I'm joining, and I haven't seen any of the lecture till now.
Lectures. It'll be there in the
Yeah.
course page. It'll be there in the course page. You can access all the lectures in the course page. If you just get onto that NPTEL website and then click on select the course, you can see all the lectures of the course. And live interactive sessions are also recorded, and the link of that will also be put up in the course page. Okay. Is it fine, Malavika?
Okay. Thank you, ma'am. Thank you so much, ma'am.
Okay. So that will also be there in the course page. And your first assignment deadline is on 9th of August. Similarly, your second assignment deadline is on uh, 9th of August. So tomorrow again from 6 to 8 we'll be covering the week 2 content, brief recap of the lectures of week 2, and also we'll solve some example questions. I guess we have one more student here. It's Arun Kumar. Hi, Arun Kumar. Can you just give a brief of yourself?
Good afternoon, ma'am. Yeah, myself Arun Kumar. Um, I am a old student in rubber technology, BTech in rubber technology.
Okay.
I completed my graduation in I think around 2001.
Oh, okay.
So I want to do a refresher.
Okay.
Actually I already moved to IT field, but I thought I will do some refresher because maybe it might help in the AI or ML related things on the polymer science. I'm dreaming weird, but I thought I will do one refresher
No,
and see.
no.
That's
See,
all.
in polymer, field again, lot of AI and ML work or machine learning and artificial intelligence work are going on. Okay, you need not feel that it is weird. Lot of works are going on. If you just go through, there are lot of papers, lot of people are working on this. Okay,
Hmm.
so
Hmm.
you can
Sure.
really, start working on that. Okay, you can just, as you said, you can have a refresher on this course and you can start working on that. Maybe you can just start going through, some papers also related to that. There are a lot of works going on. Okay, you can just
Sure.
go through
Sure.
some papers and all. In all the top universities, researchers, PhD scholars are working on this as well. Okay.
Hmm.
Okay.
Okay, ma'am. Okay.
Okay. So
Thank you.
welcome, Arun, and we have one more student here. Uh, if I think the name started with V. Uh, if you're there, can you just give a intro of yourself? or we lost the connection. Probably we lost the connection of the person. Okay, maybe we. Yeah. Vashu. Hi, Vashu.
Yes, yes, ma'am. Good afternoon, ma'am.
Yeah, good evening. So you can just give a brief intro of yourself.
Yeah, ma'am. My name is Vasulamba, and I am a student of polymer chemistry.
Can you just repeat? I think your voice was a little disturbed.
Yeah, ma'am. My name is Vasulamba,
Okay.
and I am doing my MSc specialization in polymer chemistry
Okay. Okay. From which university?
from CCS, Chaudhry Charan Singh University, Meerut.
Where? Meerut. Okay, from Meerut. Okay, okay. Okay. Okay, welcome, Vashu.
Yes,
So
ma'am.
now let's again get back to the session. So,
Yes, ma'am.
yes. Yeah. So we had a brief recap of the week one lectures. Now we'll get on to the week one practice assignment problems. Okay. So let's get on to the first question. Which of the following polymers are polyesters? Uh, so the options are polyacrylic acid, polylactic acid, polyhydroxybutyrate, caprolactone. This is again a GATE 2022 question.
Caprolactam.
Okay, someone said caprolactone. So is there any other option or it's only caprolactone? What is it? Maybe if you are not able to speak or some disturbance is there, you can just type in the chat box also. Hello? You are all able to hear me?
Yeah, ma'am.
So
Yes, ma'am.
yeah, so just tell me, I'll just show up the screen again. So what are the polyesters in this set of polymers? One person told polycaprolactone. Is there anything else or only polycaprolactone is a polyester here?
Polycaprolactam.
Only polycaprolactone. Okay. Okay. So everyone agrees with that, is it?
Yes, ma'am.
Okay. So it's only one answer, polycaprolactone. Anyone want to take any other guess or shall I say the answer?
Ma'am, polylactic acid.
Okay. Okay. What else? Is it done or anything else is there? Shall I tell the answer or shall I wait for one more minute?
Ma'am, tell the answer, please.
Okay.
No, this is caprolatum. According to me, it is nylon based. No.
Okay. You're saying capital. Okay. Okay. So now let's see the actual answer. Okay. It's actually three polymers here are polyesters. It's polylactic acid, polyhydroxybutyrate, and polycaprolactone. Let's see the structure. So polylactic acid, again you have this uh, CCH3COO, right? This is again your ester group. Okay, so polylactic acid, as someone said, I think Malavika, that is also a polyester. And then polyhydroxybutyrate. If you see the structure, again you have the ester group here. And then polycaprolactone, as everyone said. Okay, these three are polyesters here. Okay, and then polyacrylic acid
Okay.
is only the polymer that is not a polyester. If you see the structure, it is just CH2CHCOOH. Okay, this is not an ester. The remaining three are esters. Okay, polyesters. Okay. Okay. Okay, we have one more student, Aarti. Hi, Aarti.
Hello, ma'am.
Hello. So just tell me about yourself.
Myself, Aarti, pursuing BTech Textile Technology in Anna University, Chennai.
Okay, you're from Anna University, Chennai. Nice, welcome. So we just started, we had a brief recap of week one lectures, and then we just started, doing some practice assignment problems. So let's proceed with that. Okay?
Okay.
Yeah. Now, next question. Which one of the following is an example of biodegradable polymer? Here again, this is a GATE 2021 question. So the set of polymers given are polyethylene, polyamide 6,6, polypropylene, polylactic acid. So which of them are biodegradable?
Polylactic acid. Polylactic acid.
Okay, polylactic acid. Is there any other answer? Anyone
And
else?
polylactic acid.
Okay. Anyone else?
Polylactic acid.
Anyone else? Any other try? Any other doubt? Okay.
According to me, only one. Polylactic acid.
acid.
Okay.
Polylactic acid.
Everyone is unanimously saying polylactic acid, and yes, it is polylactic acid. Okay. Next, the polymer with minimum number of branches is, so there are a set of polymers given here which is having the minimum number of branches. Is it LDPE?
High density polythene.
Okay, okay. Before I finish the question, someone said it's HDPE. Okay. So let me also finish the question. Is it LDPE, LLDPE, HDPE or VLDPE? So anyone else? One answer I got is HDPE. So anyone else wants to give a try? Anyone else?
No, this is HDP because that's why the high density is increases with the low branching.
Okay, very good. You gave some explanation also. Okay, that's very good. Nice. So we have
Ma'am, HDP.
HDPE. Okay. So all are saying HDPE. Yes, it is HDPE. So if you look into the structure, so low density polyethylene, it is having a lot of branching. Your high density polyethylene, it is having very low branching. Your linear low density polyethylene is also having some branching. Very low density polyethylene is also having considerable branching. So it is the HDPE which has minimum number of branches. Okay. But does this branching also affect processing?
Of course,
Yes.
clearly branching is affecting.
Yes, yes, it does affect processing, and it is little difficult to process the lesser branched HDPE. So, thoughts on or the trials on, mixing some branching or inducing some branching is also, tried. And in fact, this is, kind of point of research and question, especially in polylactic acid than here in, LDPE. In polylactic acid, which is again a very linear polymer, the processing is difficult. So, but it's it's a biopolymer, it's a biodegradable polymer. So, the thoughts of branching on helping the processing better is considered. This was discussed in the lecture, one of the lectures. I think everyone remembers that, right? Okay. Now let's go on to next question. The functionality of adipic acid for condensation reaction with glycerol is, what is the functionality of adipic acid for condensation reaction with glycerol? This is again a GATE question, GATE 2022 question. Any answers? Okay, Harshal has said 2. Okay. Why do you say it is 2? And does everyone okay, Malavika Mohan says 1. Harshal, I guess your voice is not clear. Maybe you can just type it in the chat box.
Ma'am, adipic acid is the one with two carboxyl groups. That may be the reason with the functionality 2.
Okay, okay. So there is one answer by Harshal saying it is two. The functionality is 2 because it is a dicarboxylic acid having 2 carboxylic group. And then Malavika says 1. So why do you say so, Malavika?
Because it is a condensation reaction.
Okay, so you're saying it is only 1. Okay,
Hmm.
okay. Let's hold on. Anyone else wants to give a try? Okay, let's see what the answer is. So as Harshal said, the answer is 2 because it is a dicarboxylic acid. So it is going to be not just a condensation reaction, it's going to be polymerization, right? So again, this OH group will react with the glycerol. Glycerol is having OH. So there will be an ester bond formation from this side. There will be an ester bond formation from this side also, right? So that is why the functionality is 2. Okay. Hope you got it cleared, Malavika. As you said, it is a condensation
Yes,
reaction,
ma'am.
but in both sides, the COH will get connected to a OH because it's going to form a polymer, right?
Okay, ma'am.
Yes. Okay. Now next, identify the polysaccharides from the below: keratin, polypropylene, collagen, RNA, pectin.
Maybe pectin.
Okay, there is one answer, maybe pectin. What about others? Do you have any option or thoughts? Or do you agree with the answer? Okay, someone is saying keratin. Okay, one person told pectin, one told keratin. Anyone else wants to give a try? Or let's go with pectin and keratin. Okay, what other options do you think? Or should I say the answer? What other options do you think? Okay, I think there is no more answers. It is actually pectin. Keratin is again a protein. This keratin is present in human hair, nails, and similarly, the claws of, birds, right? The hair in animals. Okay, it's again a protein. Polypropylene, it is a synthetic polymer. Collagen is again a protein. RNA is a nucleic acid, polynucleic acid, and pectin is a polysaccharide. And if you look into the structure, it has galactonic acid as a monomer unit. This is actually the simplest form of pectin, that is homogalactone, that is galactonic acid, chain of galactonic acid. But pectin is it's actually the much more complex. So this is the backbone, but depending on branching, and there is also some other arrangement, like it comes in alternation with the galactonic acid, and rhamnos come in alternation. So that is called rhamnogalactone, and that is also pectin. So it's much more of a complex material. This is of a simplest part of the backbone part of the pectin, which is made up of homogalactone, and it is a polyelectrolyte because it is having COH group. So this will form COO minus and H plus. Okay. Hope you all got it. So shall I proceed with the next question?
Yes, ma'am.
Okay. Next question. Identify the type of tacticity in the below figure. So you have 3 figures A, B, and C, and you have to find out what is the type of tacticity, whether it is isotactic, syntactic, or atactic. So does any of you know what is this isotactic, atactic, and syntactic?
syntactic is A option, or B is a isotactic, C is a atactic.
Okay, does everyone agree? Agree, Manshi is saying agree. Okay, now let's see the answer. The answer is A is isotactic, because all these benzene rings are in one side and H is in other side. B is syntactic because there is an alternate arrangement, right, of this benzene ring and H on both sides, right? And atactic is option C, because you do not find any repeating here. In the first, there is a H in one side. In the second, the benzene ring is there, whereas next you have again H, and then again H, but and then in the right side you have the benzene ring. So there is no a repeating thing that is happening. Okay, that is atactic. Okay.
Sorry, ma'am, I'm leaving because I'm not prepared for this one. Means I have some other.
Yeah.
This every day this is happening the same time.
No. See, this week actually, today and tomorrow it is happening. Okay.
Because I saw yesterday also there now.
Yeah, yesterday it was by a different person. So this actually
Ah,
happens weekly twice. One on Saturdays 4 to 6, and other on Sundays 5 to 7. So this,
because by chance I log in. I saw this link. That's why I joined. So I found that this tomorrow is also happening.
yes. Tomorrow also it's happening. Tomorrow also I'll be taking, and then I'll be covering the week 2 content, and I'll be solving some example problems. And from this Saturday onwards, it will be Saturdays 4 to 6 where I'll be taking, and Sundays 5 to 7 there is one more scholar who will be taking. Okay.
Okay. Okay. Thank you. Tomorrow I'll join. Okay. Thank you.
Okay, fine, thank you. Okay, so people, you understood what is isotactic, syntactic and atactic? We'll go to the next question. Yes, okay. Now, okay. Metallurgical polymerization leads to dash of the molecular weight. This was again discussed in the processing, I guess. This is from your lectures only I took. Molecular weight, it helps in anyone remembers, or shall I just proceed with the answer? I think no answers. It actually helps in narrow distribution of molecular weights. We know that the molecular weight has a distribution. It is not a single molecular weight because of the polydispersity, right? The number of monomeric units present in each chain might be different in a single polymer itself due to the processing. So polymerization process. So here the metallurgical polymerization, it actually helps in narrow distribution of the molecular weight. Okay. Now let's proceed with the next question. Crystalline arrangement in poly 3,4-ethylene dioxythiophene, that is P dot, and distribution of P dot and PSS domains affecting the electrical conductivity of P dot PSS thin films is an example of property determining the structure, or process determining the property, or structure determining the property, or property determining the process. Which of these? This is also from your lecture only. So the crystalline arrangement and the domains of P dot and PSS that affects the electrical conductivity is coming under which of these correlation? C. Someone said C, structure determining the property. Okay. Anyone else? C. Vashu is also saying C. Kirti Vasan said C. Anyone else wants to give a try?
Yes, C, ma'am. Yeah.
C. Okay. Okay, so as you all said, it is C. Yes, the structure is determining the property, because the structural arrangement, the crystalline arrangement, how the crystalline arrangement is happening in P dot, and how is the domains in P dot and PSS, right? That is actually affecting the electrical conductivity of the P dot PSS films. That means the structure is determining the property. Okay. Now let's go on to the next question. During rubber processing, dash occurs and the rheological property changes. What happens during the rubber processing that affects the rheological property change? That makes that the processing will affect the structure. So the property affects the structure. I'm sorry. It's property affecting the processing. So yes, Kirtivasan said it is cross-linking. Sorry. Yes, cross-linking actually occurs during rubber processing, which affects its rheological properties. So we have to understand the rheological property change will happen, and then we have to accordingly design the rubber processing so that you do not find difficulty in processing. Okay? Okay. Now the last question for the session. So the question is, here again this is a GATE question, GATE 2022 questions. So the question is, if 5 gram of monodisperse polystyrene sample of molecular weight 10,000 gram per mole is mixed with 15 gram of another monodisperse polystyrene sample of molecular weight 20,000 gram per mole, then the polydispersity of the resulting mixture is dash. What is the polydispersity? They've asked for polydispersity index. Now how to go about this? How to go about this problem? Any thoughts? What are the things they have given? What are the informations they have given? And how do you find the polydispersity index? Any thoughts? You need not be right. Yes, Kirtivasan is saying the polydispersity index can be found by determining the weight average molecular weight by number average molecular weight. Now, how do you find out the weight average molecular weight and number average molecular weight? Any thoughts? And how do you determine the weight average and number average molecular weight from the given parameters? Someone wants to give any insights, or shall I just proceed with explaining the problem solution? The question is here for you to go through once again. Okay, everyone is silent. So let me proceed. Okay. So solution is as follows. So what is it asked for? They have asked for the polydispersity index. And what is the formula for polydispersity index? As Kirtivasan said, it is the ratio of weight average molecular weight to number average molecular weight. And how do you find the weight average molecular weight? It is summation of NIMI square by summation of NIMI, where Ni is the number of molecules having I monomers into molecular weight of that molecule square divided by NIMI. Again, Ni is the number of molecules having I monomers, and Mi is the molecular weight of that molecule. Okay, and number average molecular weight is summation NIMI by summation Ni. Okay, you're all clear, right? Now what is given? They have given monodisperse polystyrene, two different types of monodisperse polystyrene. So one is having a way, they're taking 5 gram of that, and the molecular weight of that is 10,000 gram per mole. Now, do we have all the informations for this Ni and Mi from this?
Yes, ma'am.
Okay. what is Ni in this case or Na in this case? How do you find Na? What is Na? Is the information given on Na? Actually, it is not given straight away, but you can calculate because you have the weight and the molecular weight. So Na can be calculated. Weight by molecular weight will give you the number of moles of polystyrene having a molecular weight of 10,000 gram per mole. Correct? With A monomers. So that is 5 by 10,000, 5 into 10 power minus 4. Similarly, the monodispersed polystyrene, the next 15 grams having a molecular weight of 20,000 gram per mole. Here again you can find out what is the number of moles of that. So that is WB by MB. 15 by 20,000, that is 7.5 into 10 power minus 4. Okay. Next, you have all the parameters. You have Ni, Mi. So you just have to incorporate into the weight, average molecular weight formula. So you have Ni. So it is Na Ma square plus NB MB square divided by Na Ma plus NB MB. Correct? So it's 5 into 10 power minus 4 into 10,000 square plus 7.5 into 10 power minus 4 into 20,000 square divided by 5 into 10 power minus 4 by 10 into 10,000 plus 7.5 into 10 power minus 4 into 20,000. You will end up with the weight average molecular weight as 17,500 gram per. Similarly, you have to incorporate the values into the number average molecular weight formula, and then you will end up with the number average molecular weight as 16,000. So you can get the dispersity index, right, by dividing weight average molecular weight by number average molecular weight. So 17,500 by 16,000, you will end up with 1.09 as the polydispersity index. Okay. Hope you are all.
Yes, ma'am.
You're all clear. Okay. The question was not straightforward,
Yes,
but you can
ma'am.
just calculate what is the Ni. Correct? Yes. So,
Madam, I have one doubt, madam.
yes.
And the final exam questions like this are different, madam. Assignment questions like this are a different question.
I'm really not sure. Maybe towards the end, you may be having a mix of these, multiple choice questions, some problems. It might be a mix. I'm really not sure. Maybe towards, once you start approaching the final exam, you will be given instructions by the NPTEL. Okay? You need not worry.
Okay.
Just
Okay,
try to
thank you.
understand the lecture. Okay? Try to understand the concepts. Okay, and whatever doubts you have, get it cleared, and then try to solve all the problems, the practice assignment problems, the actual assignment problems, and whatever we are solving in our interactive sessions. Just go through those again, and whatever doubts you have, get it cleared. Try to understand the concepts. That is more important. Okay, if you start doing that completely, whatever form the question comes, you will be able to answer, right?
Okay, thank you, madam.
Yes. Okay. So
Ma'am,
that's
what about the 24 October exam that will be conducted on the center or online mode?
Uh, I guess I really don't remember. Maybe I can just check. I think it happens in center generally, right? If anyone has taken any course,
Online mode,
online
madam.
also it happens. Yeah, online only it happens, right? I'm really not sure of that. I don't remember actually. I don't remember actually. I think it happens online, right? Or it depends on some courses. There might be some online and offline also. I'm really not sure. These things on the final exams, the pattern of exam in their final exams you will be getting to know towards the end probably. Or if I just get
Yes.
to know, I'll just let you know in the following sessions. Okay.
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 Hello, madam.
Yes. Yes.
Yes, I have one question regarding this molecular weight distribution, because during the lecture, professor mentioned there is we follow normally the discrete and the continuous distribution.
Yes.
So for this problem, you mentioned the calculation is normally follow the discrete one. So what's about the continuous? So when we'll follow this continuous
No.
distribution?
See, both are followed. Uh, Discrete. See, for example, in this case, whatever we solved, we have this, information. The system is just a mix of two different polymers, right? So you get to know. So you can, easily use the discrete. So some cases, you really do not know, how it really varies and how many blends of polymers you're taking, multiple, this one. So there you go for some continuous calculations, continuous, you use that integral formulae and all. Okay.
Okay.
Hope you understood.
Okay. So the thing is that when we do not know exactly the number of polymers blending or mixing, so during that case we need to follow the continuous
Probably
function.
in that case, you may not, you may need to, follow that, and then you may have to back calculate things, right? Where it becomes much more of a probability, right?
Yes.
Yes. So there you
Okay.
use more of this integral continuous distribution, right?
Okay. Okay. Thank you, madam.
Yeah. Maybe if maybe in the next class, if you still have some more doubts, maybe I'll just get back to you further. Okay.
Okay, madam.
Okay. Okay. Any other doubts?
Hello,
Yes. Yes.
Kritika ma'am.
Yes.
I have small doubt regarding acrylic copolymerization or free radical polymerization.
Okay.
When we perform emulsion polymerization for getting polymer of certain TG, glass transition temperature,
Okay.
so we use Fox equation for the selection of different monomer combinations.
Mm-mm-mm.
Please correct me if I'm wrong.
Okay. Yes, I do remember that way. Maybe
Uh,
maybe if you just finish off your question, I'll just
uh, and then practically how we can determine the TG with either DSC or TGA.
TG of each component you're saying.
Uh, how you will determine the glass transition temperature of final polymer film.
See, that's where you do this. What is it? Your DSC.
Yes, correct.
Yes. You do your DSC and find out, what is the glass transition. With the, curves, you get to know what is the glass transition of the complex. It is not only with, the, maybe you can just mute your mic because there is a lot of disturbance. Yeah. So, whether it is a polymer blend or polymer composite, or, you do not know what are, there may be systems, you may tentatively know that these may be present, but you do not know actually what is, especially in case of natural polymers and all, no, natural materials, you may not know whether it may not be made up of just single polymer. Okay, like single pectin alone, for example. There may be systems where there may be pectin, cellulose in natural materials and all, no, it will be a mixed complex. So there and all, you just find out, you just take the sample to a DSC, find out the do the DSC, do a DSC experiment, and then find out what is the glass transition temperature. And sometimes you may have to do other techniques to find out, which is actually the dominant component of that, uh, which is actually contributing major to the glass transition. So there may be some components in very minor quantities, so that may, really not have an impact. Sometimes, there may be blend of two materials alone which will equally contribute. So one may have a 60-degree, one may have a 120-degree. So somewhere in between your glass transition will be. Some cases it will be like towards, say for example 60 and 120. Sometimes you will get in that combination, you will get a glass transition for the complex as something around 100 or 110. That means that second material having 120 is, much more prevalent in that, and that is really playing a role. So those kind of, exploratory research you have to do. I think hope you're clear with that.
Yes, ma'am. Thank you.
Yes.
And I have another doubt, small doubt.
Yes.
When we play with different monomer combinations for acrylic copolymer latex, uh, then how you will come to know that all monomer combinations are polymerized? Means what may be the sophisticated analysis technique for getting confirmation that all the monomers you have used, they are polymerized?
I'm really not sure on that.
Okay, okay,
I'm
no
really
issue,
not
ma'am.
sure on that. Okay. Maybe you can just post this question in the you know forum, so that even the
Okay,
course instructor can give you a better insight on that, or I'll get back to you maybe in tomorrow or in the later lecture. Okay.
maybe if anyone from the audience, maybe
Yeah, that's also true.
they may help to me.
Yeah, someone.
Okay, ma'am, no issue. Thank you.
Okay. So your first question was on what we discussed is that if it is a combination, then how do you find the DSC? I think, right? Sorry, how do you find the glass transition? Right? Combination of
Yes,
yes.
yes, ma'am. Yes,
How to find the glass transition? I think you got some insight on that.
yes, ma'am.
Your second question is if different monomers are there.
Yes, while playing with the different monomer combinations for getting acrylic copolymer latex, how you will come to know that all the monomers are getting polymerized? What may be the confirmatory test or sophisticated analysis? FTIR may be the right one or appropriate one.
But I'm not sure of, because in FTIR, you just get to know the functional groups. So, see, sometimes the monomers may have similar functional groups again. So, you do not know whether that monomer is also has played, or sometimes if both are having actually a kind of an acidic monomeric group, COH
Correct.
group. So, you may
Yes.
end up in a uh, that might be a little kind of a complicated, unless and until for each monomer you should know where exactly this peak might come, because there may be very small variation, even if it is going to be this CO stretching or stretching or CH2 vibration or something also. No, there might be some minor variation. So if you have to go through the literature and really find out and map out whether that it is belonging to that monomer, but that may be a very complicated uh, you know procedure. I'm really not sure if there are any other sophisticated procedures where you could get to know whether all monomers are actually uh, in the part of polymer form.
Polymers. Correct. Okay. Okay, ma'am. Thank you. Thank you so much.
Okay. Yeah, maybe I'll get back to you, or you can just post these questions in the forum, so that even the course professor, he'll be having much more information, right? So he'll be able to answer in a greater precision to you. Okay. And yes, that is one more thing. Okay. uh, is there anything else, any other doubts anyone has? Okay, Harshul, thank you. So anybody wants to know anything else, any other? If there are no doubts, then we can officially close the session for the day. Tomorrow we'll catch up again at 6 with week 2 brief and some practice problems from week 2 content. Hope you all enjoyed the session, and any other feedback, please let me know so that the session can further. Anything? So, any other doubt, anyone? If nothing, then yeah, Sandeep, you want to say something?
Hello? No, no,
Yeah.
no, no, madam.
Okay,
It's
okay,
okay.
okay.
So
Okay.
can I leave?
Yes, yes, yes.
Okay.
Yes, the session is officially closed. If you have any
Okay.
doubts, you can just ask.
Okay. Okay, madam. Thank you.
Okay. Otherwise, you can leave. You're not able to access the page. Maybe you can just first assignment submission. You have registered for the course, right? You have enrolled for the course, right? Manchi, you have enrolled for the yes. You're not able to see the page of the first assignment, is it? Maybe you can just write an email to the NPTEL team from where you're getting this, updates and everything. And you can just write an email immediately so that they can help you out, because you have only 2 more days left. Okay. Yes, you have 2 more days left, so you can just you know email immediately. Just now you can just email, okay, so that they can help you out.